7.2 Applications of the normal distribution. Means we're going to do word problems and answer probability questions using a normal distribution, our yellow table, or technology. So what we do is we get a z-score, and then we use the table to read the area under the curve that refers to the problem. So recall that the z-score of the data value represents the number of standard deviations of that data value above or below the mean. If the x value is from a normal distribution with a population mean and a standard deviation, we can convert the data value to a z-score, and this is called standardization. So we've done this before, taken a value and get the z-score. For example, a woman whose height is 67 inches from a normal population. That population has a mean of 64 inches and a standard deviation of 3. To get the z-score, we take that 67-inch woman, subtract from the mean, divided by the standard deviation, and we find out that she's exactly 1 standard deviation above average for this normal distribution. So we take this 1, the 67 inches, translate it to our z-table so we can use the yellow table to answer questions about this distribution. So we're going to use the table or technology to compute areas. First, get your z-score, use the table. So let's do an example. A study reported that the length of pregnancies from conception to birth is approximately normally distributed with a mean of 272 days and a standard deviation of 9 days. What proportion of the pregnancies last longer than 280 days? So we're going to be looking for the proportion or the area under the curve for an x value to the right of 280. So this longer tells me I want to the right of. So first I standardize it, get my z-score. (280 days), take away my mean of 272 days divided by my standard deviation. I'm always going to get my numerator first before I divide. So this is a z-score, so I'm going to round to 2 decimal places so that I can read my table. What I want is the area under the curve to the right of longer than 0.89. So I have to use my table to read this area under the curve. So I have positive 0.89, 0.8 over to 9 is 0.8133. So because I want to the right of, I need to take 1 minus my table reading. 1 whole minus 0.8133 gives me 0.1867. So that's the area under the curve shaded to the right of this z-score. So this z-score is exactly 0.89 standard deviations above average. To the right of that is 0.1867. And that means 18.67% of the population, their pregnancies last longer or more than 280 days. So the area under the curve is the proportion of the population that they're talking about. It's also the probability. All those words refer to the area under the curve. Let's try another one. The length of a pregnancy from conception to birth is approximately normally distributed with a mean of 272 days and a standard deviation of 9 days. So we're talking about the same normal distribution. But this time, we need to know that a pregnancy is considered full term if it lasts between 252 days and 298 days. What proportion of the pregnancies are full term? What is the area under the curve between these two x values? I'm going to need two z-scores. So 298 minus the mean divided by my standard deviation get my numerator first. I'm going to round this to 2 decimal places because this is a z-score. I'm going to get my other z-score for the 252 days. This rounds to negative 2.22. So I want the area under the curve you don't have to draw a picture. I'm just going to do it for help. 2.89 would be over here, negative 2.22. So we want all these, the proportion of the population of all this shaded region between these two values. So the area under the curve will give us the proportion of pregnancies that are full term. So when I want something between, I need to take the big reading minus the small reading. So 2.89 on my z-table, my normal distribution, over here, last column, 0.9981 minus the smaller reading is negative 2.22 0.0132. So the area under the curve shaded is 0.9849. So 98.49% of the population, or the proportion of the population of these pregnancies are full term. 98.5% I could round to. So the area under the curve is the proportion of the population of this distribution of pregnancies that last between these two x values.